Hours breaking news from Malaysia. The country will enter a full lockdown from the 1st of June for 2 weeks as COVID-19 infections there surge.
Malaysia has confirmed its first citizen to be affected. The country has now 10 confirmed cases. This goes in Kuala Lumpur.
Known that tourism is the worst hit industry, and then we are the third contributor to our economy, about 15.3% from tourism. And now we have, from January to March, we have lost about 9.9 billion ringgit. And then very soon it will be worse than that, because this is the peak of where this COVID-19 had been hitting us all.
Avengers! Assemble.
Prime Minister Tun Dr. Mahathir Mohamad today unveiled the Visit Malaysia 2020 official campaign logo and set a target of 30 million international tourist arrivals next year. He also said...
Hi everyone, how are you? I hope you all are doing good. So this is Imran here, and today we are trying to do some understanding analysis of our statistics projects. So in this project we are supposed to do three analyses. The first one is descriptive analysis, the second one is the forecasting analysis, and we will also see some relationship of the variables. So what we did, we tried to identify some data sets of the tourism history of Malaysia for the fiscal year 2002 to 2020. We have taken a data set of 20 years, and we'll try to analyze all these data into various variables, and we'll try to understand that why the tourism industry is hit so badly, and how can we overcome in the coming years with some forecasting analysis, that how could be the trend of the 2021 and 22. So we'll try to do some forecasting trends, and we'll try to see that whether which forecasting trends will be the best fit in. So let's start with, I'll try to show you some descriptive analysis of our data sets, then how the descriptive analysis actually looks like. So in the first visual, we can see that number of visitors came to Malaysia was highest back in 2018 and 19, and we do some normality test of this trend or of this data set. So we'll see that the significant levels, as we know that we normally try to analyze the significant levels in two ways. The first way is the Kolmogorov way, and the second way is the Shapiro-Wilk way. So if the value of the significance was more than our standard range, which is 0.05, then we normally say that yes, we can accept our null hypothesis. So in our case, we have seen that from the Kolmogorov normality test, we have found 0.200, and from the Shapiro test, we have seen our significant value is 0.206. So clearly we can say that this is quite higher than our standard range. So we are going to accept our null hypothesis. On the other hand, if we see the skewness value and the kurtosis value, we'll see that those values are in minus figures and quite far away from the standard range. The standard range is 3.0, and those values are one is minus 0.34, the other one is minus 1.309. So clearly we can see that these two values are quite far from the standard range. So we can understand from this value. After this, if we see the QQ plot, we'll see that the data set is little far away from the standard line. So if the data sets were very closely with the line, or even it is on the line, then we can say that data are very close. The data sets a little far away from the line is simply because the kurtosis is in a negative shape. So we can have some understanding of our QQ plots here as well. Now I'm going to some analysis of the hotel industry, how the hotel industry grown in the last 20 years, and how about what is the situation of the room occupancies in the last 20 years. So with those things, I can see that the number of hotel industries grown in Malaysia back in 2012 and 2015 was highest, and the second highest was 2018 and 19, and the data set is distributed quite normally. If we see the bell shape of the data, we can see that it is evenly distributed. And then if we go to the room occupancy levels for the last 20 years, we will see that this bell curve is rightly skewed, and again we have seen that a number of occupancies for the fiscal year 2012 to 2016 was quite high, and 2018 to 2019 was also quite high. So with this, I think we can summarize our descriptive analysis, and our next team members, they'll try to identify some relationship between the variables, some coefficients, and most importantly, finally, what we actually try to understand, want to know from this study or from this research is that how is going to be the best fit model of our forecasting. And forecasting, we are trying to do a forecast for the fiscal year 2021 and 2022, and which forecast is the best fit model. So we'll see all those things in our coming slides. With this, I thank you all. Thank you.
On this chapter, we will statistically explore a scenario where COVID-19 pandemic never happened, and the Visit Malaysia 2020 campaign took off the tourism industry to a greater achievement. Objectively, we will make a statistical prediction about two variables, which are: 1. The number of international tourist arrivals from 2020 until 2022. Second, the total receipt of tourist spending from 2020 until 2022. To achieve the stated objective, a term of references was developed to identify the best forecasting model that can significantly predict the variable's value. We will use four types of forecasting model that comprises of a linear regression model, two-level polynomial nonlinear regression, three-legs moving average model, and an exponential smoothing model. Each model will be built using Microsoft Excel software suite and will be statistically tested with slope coefficient significant test using p-value at significant level of 95% or alpha equivalent to 0.05. Next, to test the predicted model fitness level or R-square, then to determine the mean absolute deviation between actual data to the predicted value. Lastly, the data set is sourced out from Tourism Malaysia from the year 2000 until 2019. There are no missing data observed. As observed from the dataset table, in 2019, the number of tourist arrivals were recorded at 26.1 million and spending ticket were at 86.1 billion ringgit. Our task will determine the variable's value for the following years until 2022. Now, how does time series forecasting work? Time series forecasting is a statistical tool that use past data information to predict future demands. There are three of the simplest forecasting model widely used are trend forecasting, moving average, and exponential smoothing. The step for building a forecasting model starts from selecting the simplest model. Then, using the dataset, a prediction model or a mathematical formula is built using tools such as IBM SPSS, Python, or Microsoft Excel software. Next, the model built will be diagnosed its fitness and significant level. We have built 6 predictions for tourist arrival variables: a linear regression model, a nonlinear regression model with level 2 polynomial, 3-leg moving average, and an exponential smoothing with 4 different smoothing constant, which is alpha equivalent to 0.2, alpha equivalent to 0.5, and alpha equivalent to 0.8. These are the findings we observed from the model diagnostic test. For linear regression, p-value of the t-slope coefficient is less than alpha equivalent to 0.05, which means that the regression slope is significant for predicting the number of tourists. Secondly, percentage of the model fitness represented by R-square is equivalent to 0.85, which means that the model explains 85% of the actual value of Y, numbers of tourist arrival, while the mean absolute deviation is at the fourth smallest value among other models that have been built. For the non-linear regression, the regression slope t and t square appears to be statistically significant to the model, while R square is at 95% fitness to explain overall actual value. MAD value was the smallest observed. Moving to moving average model, MAD was the second smallest value. Meanwhile, the 3 variations of exponential smoothing were recorded to be in the MAD order of alpha equivalent to 0.2 has the biggest MAD value, alpha equivalent to 0.5 has the second MAD largest value, and alpha 0.8 has the third smallest value. From this finding, we observe that the nonlinear regression model has the smallest MAD value and fulfill model fitting requirements. Thus, we concluded and choose value predicted from nonlinear regression to represent numbers of tourist arrival, which are, in 2020, near to 26 million tourists are expected to arrive, while in 2021 until 2022, the figure hover in the range of 25 million bracket. Similar model was used for forecasting the amount of total tourist spending. Here are the findings. For linear regression, p-value of t-slope coefficient is less than alpha equivalent to 0.05, which means that the regression slope is significant for predicting the total spendings. Secondly, percentage of model fitness represented by R square is equivalent to 0.98, which means that the model explains 98% of the actual value of Y tourist spendings, while the mean absolute deviation is the smallest value among other models that have been built. non-linear regression slope of t square, p-value appears to statistically not significant to the model because the value is bigger, the p-value is bigger than alpha 0.05, while the R square is at 98% fitness to explain overall actual value. MAD value was the second smallest observed. Then, the moving average model, MAD was third smallest in the value. The three variations of exponential smoothing were recorded to be in the MAD order of alpha 0.2 has the biggest MAD value, after alpha 0.5 has the second MAD largest value, alpha 0.8 has the third largest value. We conclude that linear regression model is the best prediction model because it has the smallest MAD value while fulfilling all model fitting requirements. The predicted value from the linear regression suggested that during Visit Malaysia 2020, Malaysia will reap in nearly 92.5 billion ringgit in tourist spending, and for the next subsequent years, the value will increase to 96.4 billion and 100 billion in 2022. Slide 21 and 22 will show the summary and charts representing the numbers. Before I wrap up, it is interesting to make comparison with the Tourism Malaysia prediction, which is more than we have made. However, we have no information which model does this estimate are based on. Thank you.
In the first slide, we are going to talk about the people who has visited Malaysia during 2000 until 2004, between 5 years only, starting in 2000 with 10.2 million people who has visited Malaysia until reached to 13.3 million who has visited Malaysia until 2002. After that, the number of the people are decreased slightly, reaching to 10.5 million tourists who has visited Malaysia during that time. Between 2003 and 2004, the number increased sharply and it reached to 15.7 million tourists who has visited Malaysia in that time. In the second slide, we already see from the database which we got it from the government website that the number of the people who has visited Malaysia for the tourism purposes during 2005 until 2009 has increased dramatically, reached to 16.4 million during 2005, and 2006 reaches to 70.5 million and reaches to the maximum number during this period between 2000 and 2009 with 23.6 million tourism who has visiting Malaysia through the airport or through the local boarding by this time. During 2010 and 2014, there were a slight difference between the number of the people who has been arrived to Malaysia in that time. In 2010, it was 24.5 million people who has visited Malaysia, and this number increased slightly, reaches to 27.4 million who has visited Malaysia during 2014. In 2015, the number of the tourists who has visited Malaysia was 25.7 million, and this number increased slightly in 2016, reaches to 26.7 million, and this number also decreased again and reaches to 25.9 million tourists who has visited Malaysia. And between 2017 and 2019, the number was fluctuated between 25.9 million and reaches to 26.1 million. As you can see here, the number of the people who has been arrived to Malaysia during 2019 after the COVID-19, after the country locked down to break down the COVID-19 spread hit, the number of the people who has been arrived is only 4.3 million people during 2020. This number was 26.1 million who has been arrived during 2019 before the COVID-19. Also, the incomes has been decreased by 85%, only reaches to 12.6 billion ringgit during this time. So we are thinking, what is happening for this COVID-19? Can we get the data and forecasting the number of the people who will be arrived to Malaysia during 2021 and 2022? In this article, we tried to find more data about the people who has been arrived monthly, but we couldn't find it. We are depending on the data which we do have, and we will try to forecasting by using different methods like exponential smooth and also moving average to try to predicate the people who has been arrived to Malaysia during 2021 and 2022, and try to figure out if our prediction will be good by using different alpha. We had faced a huge challenge. The number of the database which we found it for the people who has been arrived to Malaysia during 2020 and 2021 is not yet released. Only we found the data for 2020, and almost of the forecasting depending on the forecasting method depending on the average. We try to figure out if our forecasting will be okay or not by using different methods and also different algorithm to try to predicate the number of the people who will be arrived to Malaysia during 2021 and 2022. We will try to predicate the following: forecasting for the tourism people who will be arrived to Malaysia during 2021 and 2020. The second thing is the amount of the money which we will be income for Malaysia during the same period of the time, 2021 and 2022. We will do the forecasting by using Microsoft Excel, different methods, and also by using Power BI. And we'll try to calculate conclusion what is happening for the data and if the data is correct or not, or we have leaked of the data.
This is the database which we will use it for forecasting in this chapter. It contains the years 2000 until 2020 and also the number of the people who has been arriving to Malaysia for the tourism between that given year, and also the receipt amount between 2000 and 2020. By doing our examination or the data, we will do selecting the forecasting model and also building the model and diagnose it and model fitting. We will see how to do that in the next slides. Here in this slide, as you can see, we already tried to do it by forecasting by using moving the average. We got this result for the forecasting error, and absolute value for the error, and for squared for the forecasting. As you can see down on the table, there are some values for the MAD, MSE, and RMSE. The MSE is representing the value between the actual value and the forecasting value, the average for it. And also, if you can see here, by moving the average, the line graph is already showed between the actual graph and also forecasting graph. Here, as you can see, we use different programs for the forecasting. We use Power BI exponential smooth. In the Power BI, they are depending on the exponential smooth algorithm. We try to predicate how many people will visit Malaysia for the tourism during 2021 and 2022. You can see here the difference between this one and the moving average way. There is a huge difference between them, about 8 millions. Here the people who are coming to visit Malaysia as the program predicate is about 10.2 millions in 2021 and reaches to 12.87 millions during 2022. While in moving average, this value reaches to 20 millions. That's one because the different algorithm are using to predicate. In this slide, as you can see, also we're using exponential smooth for the same data set. but we use it by using Excel. We got different ways for the predicating and also for the mean value error. For the predicating in 2020, 2021, there is a slight difference between using this algorithm in Power BI and also in Microsoft Excel. The number is almost same, 10 point something millions, but in 2022 the number is already difference between 2022 by using Power BI and also by using Microsoft Excel. We use alpha as 0.8 for here. In this slide we're using different alpha value. The alpha value here we use it as 0.5, and here the results which we got it down for MAD and MSE and RMSE. And also we try to do the linear graph and also for the actual and forecasting value. In this slide, as you can see, we use different alpha value. The alpha value here we use 0.2, and we try to predicate the tourists who will visit Malaysia during 2021 and 2022. As you can see, the value is a little difference between this one and another value of the alpha. In this slide, we are comparing the three alpha value. One when alpha 0.2, the second one when alpha is 0.5, and the third one when alpha 0.8. We got the lowest value for MAD when the alpha is 0.8. That means it's the best prediction line for this one. And for the performance of the modules which we built it, we noticed that RMSE has the lowest value when its alpha is 0.8 also. Another database which we use it for the income, for the tourism income to Malaysia during 2000 until 2020, by predicating the value which for incoming between 2021 and 2022 with different value of the alpha. Here we use a different value for the alpha 0.5, and we get the forecasting for the predicting value for the income for the received amount between 2021 and 2022, as we can see here in the red with these slides. And also we get the result value for MAD and MSE and MSE also. By changing the value for alpha here is to 0.8, and also predicate the value for the incomes, received amount incomes between 2021 and 2022. We got this value by using Excel and exponential smooth methods. As you can see, for our conclusion, we compare the value in the three times when alpha is 0.2 and 0.5 and 0.8. And that we discover when the alpha is 0.8, also the MAD is the lowest. And when the MAD is lowest, usually the alpha also for the performance model for the modules, it will be good. It will be the best for the value which we are testing. And we got the RMSE the lowest, RMSE when the alpha also 0.8. And again, by using also Microsoft Power BI to try to predicate by using exponential smooth also algorithm in the Power BI. And we try here for the incomes for the Malaysia between 2021 and 2022 has this value. There is a slight difference between this one for predicating this one and also for the predicating by using Excel. Here the rest of the nationalities, people who visited Malaysia between 2016 and 2017 by using visualization of Power BI. As you can see, the number of the people who are visiting Malaysia are increased from 2016 until 2020. Reaches to the highest level in 2019, and then the number are decreased sharply and reached to the lowest value between in 2020. And also here we try to visualization by using the received amount between 2000 and 2020. The number of the amount are increased year by year until 2020, then they suddenly sharply dropped, as you can see here. 2020, the number are decreased unto the lowest value during this year. Here also we try to predicate, we try to just visualization the value for the people who are visiting Malaysia by the countries, top 14 countries between 2016, 2017, and 2018, 19, and 2020. And this one is just a visualization also for the number of the hotels and the rooms are occupied between the given time 2000 until 2020. The number are sharply increased, reaches to the lowest value in 2017 and then dropped in 2018. As you can see, it reaches to the 4,512 hotels only. Thank you.